clarification has been something various suggested as the speculation of the old limitless blast. Various assessments, moreover created by a huge number of researchers, support this thought, giving affirmation about how the universe began. Anyway, the present universe of science, with new advancements, brings us novel examinations and points of view. These contemplations challenge our points of view, where sure bits of information, such as those from Neil deGrasse Tyson, have become an immense figure in this affecting universe of science. Now, something engaging is occurring with the James Webb Space Telescope. It's basic to recognize something that could make us question the speculation of the universe's beginning. The James Webb Space Telescope has tracked down 750 new universes. These systems are not exactly identical to what we anticipated, leading us to reevaluate what we thought we had some consciousness of them. This degree was supposed to help us appreciate how huge systems ended up being, so it's not dazzling that it's stirring up how we would be able to unravel the universe before. Investigators said that the Big Bang Theory was an extraordinary clarification for how the universe began. According to this theory, around 13.8 billion years ago, the universe appeared through a perplexing event, like the crazy story of the universe's preamble to the world. However, the pictures from the James Webb Space Telescope have challenged this thought. These photographs show universes that are more subtle, smoother, and older to say the least, different than what the theory of how things came to be predicts. According to the hypothesis, as the universe expands, objects should look more noticeable the farther away they are, but these pretentious structures don't keep that rule. The theory also states that at the universe's real start, all the matter that makes up the universe was fit into a moment superdense point called a singularity. This singularity was unimaginably more hot than anything that we might truly measure or create. This thought of a singularity comes from a great deal of conditions in real science proposed by Albert Einstein called general relativity. Inside the singularity, all the stuff in the universe was squeezed into a tiny space with very high density, meaning there was a tremendous amount of mass and energy packed into a little space. In simpler terms, experts have always said that the theory of how things came to be was the means by which the universe began. However, these new pictures from the James Webb Space Telescope are making us question that idea. The universes it found don't fit with what the theory expected, and the theory's explanation of the early universe might not be as solid as we once thought. In our continuous view of the universe, we recognize that all the energy in the universe began from an extremely hot and dense point called a singularity. This point is like the early stage for everything we find in the universe today. After this singularity, the universe started to expand and develop over approximately 13.7 billion years to become what it is today. The expansion began with something many refer to as the Great Inflation, where the universe became unfathomably quickly, a lot faster than the speed of light. It's as if the real surface of space itself was expanding and everything in it was stretching along with it. This boundless expansion helped shape the universe by making things more uniform and creating a way for universes, stars, and other impacted planets to form. As the universe continued to develop, it didn't expand as quickly as during the Great Inflation. However, it still kept on growing. We call this consistent expansion self-important advancement. Experts have seen evidence of this increase through things like the way light from faraway universes changes in color, known as redshift. Now let's look at those stunning pictures of new universes taken by the James Webb Space Telescope. To the majority, these photos look shocking with various universes in a single frame. However, for examiners, it's somewhat of a shock. These photographs don't match what their speculations anticipated. As a matter of some importance, these universes are essentially more prepared than guessed, which challenges our point of view regarding galactic structure and advancement. According to the theory of the ancient Big Bang, there are furthermore significantly more pretentious systems than we expected. The theory of the universe's beginning made guesses about how many systems there ought to be and how they ought to be fanned out. However, the JWST pictures show a gigantic number, many more universes than anticipated. This makes experts question whether the theory's estimates are accurate. Some researchers are even beginning to overcompensate a bit, considering the way these discoveries make an effort not to match their notions in any way. One more surprising piece of these new pretentious structures is their perfection, which conflicts with what the theory of how things came to be proposed. According to the theory, Universes ought to show irregularities and arrangements in their structures because of how they formed and developed. But photographs from the JWST show universes that are extremely smooth, without the usual complexity and violence during the progression of the universe. All that makes up our universe was fit into a tiny space. As the universe expanded and cooled, changes happened in particles like protons, neutrons, and electrons, which began to interact with light and energy around them. These interactions played a huge role in the development of matter in the universe in the first 2 or 3 minutes after the Big Bang. There was a process called nucleosynthesis, which involved the creation of lightweight elements like hydrogen and helium. These elements set the stage for the formation of stars, countless systems, and more complicated elements as endless history unfolded. This combination of basic building blocks was a critical stage in the universe's development, progressing from a starting state of particles and energy to a state where matter began to form. As expected, the theory of ancient cosmic explosions had expected to see universes that were disordered and chaotic. However, the JWST pictures tell a different story. Rather than tempestuous and scattered universes, the photos reveal smooth, circular, and capable winding shapes resembling the systems we see in the current-day universe. This startling discovery challenges the notion that chaos is a typical part of universe development. If there are few or no chaotic events occurring in these universes as proposed by the theory of how things came to be, it becomes unreasonable that tiny universes could grow to become more massive. Similarly, the optical interestingness predicted by the expanding universe hypothesis, where objects appear smaller with increasing distance due to expansion, doesn't seem to be present in space. Experts have observed a striking pattern where immense structures tend to cluster together in large gatherings, forming different networks across the universe. This massive-scale structure lines up with the assumptions made by the theory of the universe's beginning. According to the theory, the universe began in an extremely hot and dense state and then expanded and cooled over time. As the universe expanded, gravity played a significant role in shaping how matter was distributed and in organizing universes. The gravitational effects predicted by the theory of the ancient Big Bang are consistent with what we see today, with gravity organizing matter, leading to the clustering of galactic systems and the formation of interconnected filamentary structures known as the cosmic web. The presence of these system groupings and the cosmic web structure strongly supports the theory of prehistoric cosmic detonation. How systems are distributed across the universe aligns with the gravitational effects expected from an initial dense and expanding state, as proposed by the theory. These factors, counting the clustering of systems, the cosmic web structure, and the spreading of universe clusters, provide solid evidence that the universe evolved from an extremely dense state and has been expanding for billions of years. Now, let's return to the size of the structures found by the JWST. These photos contradict what we thought we knew about the Big Bang theory. According to the theory, small universes should form and extend through collisions and mergers with other universes. However, the universes made by the JWST feel quite different from this idea. If galactic structures were colliding and merging as predicted, we would see evidence of these collisions or mergers. Yet, the photographs show something different. The Big Bang is too much of a hypothesis, essentially an idea without definitive proof. No, it is really supported by undeniable evidence, including views of the redshift of light. Observations from distant universes provide support for the expanding universe hypothesis. Studies showing universes increasing their distance from one another suggest the expected consistent increase predicted by the theory. The spread of light elements like hydrogen and helium seen throughout the universe is also consistent with the theory of the universe's beginning. Additionally, the large-scale distribution of universes, as revealed through astronomical blueprints, matches the patterns expected by the Big Bang theory. One of the main pieces of evidence for the Big Bang theory is the discovery of the cosmic microwave background, CMB. The CMB is weak radiation that fills the entire universe and represents the remnant glow of the Big Bang. This massive radiation, first detected in 1965, still aligns with the predictions made by the theory of the universe's beginning. The observed characteristics of the CMB, its consistency and temperature distribution, strongly support the possibility that the universe was once in a very hot and dense state before undergoing expansion, a central part of the theory of how things came to be. The discovery of the cosmic microwave background is a critical piece of evidence that offers us a rare glimpse into the early moments of the universe. It acts as a remnant of the first stages after the Big Bang and plays a vital role in solidifying the theory of the universe's start as our best explanation for the earliest phases of the universe's evolution. Discoveries have tested some aspects of the Big Bang theory. The existence of universes with ages that appear to begin before the Big Bang conflicts with the theory significantly, suggesting that the Big Bang may not have happened as originally thought. Furthermore, the radiation emanating from the newly discovered universe's conflicts with what was anticipated from the Big Bang hypothesis. It's in this light that many rethink the Big Bang theory, especially given the recent advancements brought by tools like the James Webb Space Telescope. The research and discoveries from the James Webb Space Telescope continue to shake our understanding of the universe's origins. It's crucial to acknowledge that while these new findings present challenges to the Big Bang theory, they also open up exciting possibilities for new cosmological theories. The inconsistencies observed in the new images and data from the telescope push scientists to reconsider the standard models of cosmic evolution and examine whether our current understanding of the universe's beginnings needs fundamental revision. One of the significant questions raised by the JWST's observations is the rate of galaxy formation. The theory of cosmic evolution has long predicted that galaxies form and evolve over billions of years, with their structures developing through a process of gradual accretion and merging. However, the images from the James Webb Space Telescope reveal galaxies that appear to be much more mature and structured than expected for their distance and age. These galaxies seem to have already undergone significant processes of star formation and even the development of complex structures. Such unexpected findings prompt scientists to consider that the processes responsible for galaxy formation might operate differently from what has been understood so far, potentially involving mechanisms not yet fully explored in current cosmological models. Another surprising aspect of these discoveries is the relationship between dark matter and the evolution of these distant galaxies. Dark matter, a mysterious substance that has yet to be directly observed, but whose presence is inferred from its gravitational effects on visible matter, is a crucial component of the universe's structure. In traditional cosmological models, dark matter is thought to play a major role in the formation of galaxies and large-scale cosmic structures. However, the early galaxies observed by the JWST challenge the conventional ideas of how dark matter interacts with visible matter in the process of galactic evolution. Some scientists are now exploring whether the nature of dark matter might differ from current assumptions, or whether there could be new forms of unseen matter that have a stronger influence on galaxy formation than previously thought. The discovery of older and more developed galaxies also suggests that the conditions for galaxy formation might have existed earlier than previously anticipated. This could imply that the early universe was far more conducive to the formation of complex structures than the Big Bang theory suggests. Some researchers are now speculating that the process of galaxy formation could have been initiated by processes that occurred before the Big Bang, potentially even suggesting that the universe is cyclical in nature. In this scenario, galaxies could form in an infinite series of cycles, each one emerging from the remnants of the last. This new framework would require rethinking our concepts of time and the universe's history, suggesting that our universe's birth might not have been a singular event but part of a much broader, ongoing cosmic cycle. Additionally, the discovery of unexpected galaxy structures could signal that the process of cosmic inflation, the rapid expansion of space in the earliest moments of the universe, is not as straightforward as previously believed. Inflation theory posits that the universe expanded at an incomprehensibly fast rate immediately after the Big Bang, smoothing out any irregularities and setting the stage for the development of the universe's large-scale structure. However, the findings from the JWST suggest that certain structures, such as galaxy clusters, appear to form earlier and more quickly than inflationary models would predict. This discrepancy between theory and observation prompts cosmologists to consider alternative models of the early universe, such as those that involve different mechanisms of expansion or the possibility that inflation itself could have operated in a more complex way than we have understood. The potential for new models of cosmic evolution could also affect our understanding of the cosmic microwave background, CMB, the faint radiation left over from the Big Bang that provides a snapshot of the universe's state shortly after its inception. The CMB has been one of the cornerstones of the Big Bang theory, and its patterns and fluctuations have been used to support our current understanding of the universe's development. However, If the early universe was not as homogeneous as the current models suggest, the data obtained from the CMB could be reinterpreted to fit a new understanding of cosmic evolution. This could mean that the observable universe, as we see it today, may have a much more complex history than we ever thought. Furthermore, the possibility that our current understanding of the universe's beginning might be incomplete also raises questions about the long-term future of cosmology. New technologies and innovations in space exploration will likely continue to challenge and refine our theories of the cosmos. Instruments like the James Webb Space Telescope represent the cutting edge of scientific discovery, and as more data is gathered from deeper and farther reaches of the universe, the theories we hold today may need to evolve once again. With each new discovery, science moves closer to unraveling the mysteries of the universe's origins. And while the Big Bang Theory has served as a powerful framework for understanding cosmic history, it is clear that our search for the true story of the universe's creation is far from over.